Welcome to a special episode of Doug's Electronic Repair Bench.
Afternoon YouTube, here with you today to show you a little bit about this troubleshooting that we've been talking about. For this demonstration, what we're going to do is use the GE321. I'm going to use our signal generator, and it'll be hooked up to our frequency counter there so we can see what frequency it's on. I'm not gonna, I was going to try to see if you could figure out what I'm trying to do, but being as Bill mentioned it in the comments, I'm going to tell you right now that we're going to be trying to track down a no local oscillator problem. When the local oscillator quits, it's kind of a difficult situation to troubleshoot using this method, but it's not impossible, as you will see. Some of the symptoms you're going to see is the radio will work, and don't have it hooked up at the moment. Let's see what kind of voltage I got on there. Yep, I've got it hooked up. Okay, so it is operating. We're at 104.7 volts. Radio is on. It is hooked up to the antenna. What we're trying to find out here is if the radio works or not. Like I said, it's on. It will make some noise here in a minute. There we go. Now, this is, like I said, that's what we get. It's a staticky noise. I'm going to show you what happens when we tune across the dial. That's one end right there. You hear some staticky noises. Overall, nothing though. You might hear more static, louder static on one end or the other, depending on the frequency of things running around here on the bench. So you see there is absolutely no reception. There's plenty of noise, so we know the audio section is working. We can do that with that. Audio is working, so we don't have to troubleshoot that. Now again, what we have is basically it's not receiving any stations. So basically what I'm going to do first, and I'll put a diagram up to show you where I'm going to inject the signal. So we'll do that next, and we'll inject the signal. Now what this signal is an IF signal. It's 455 kilohertz. That will give us an indication of whether the radio is working as far as radios go. If this gets through the radio and comes out the speaker, we'll know that the radio is basically working. So hang on for that. Alright, you can see the frequency that we're putting into the and what we're putting it into is the antenna coil that's just laying there against the antenna of the radio. It is hooked up to the we follow it over here to the frequency or signal generator, and again that's I'll show you to demonstrate. That's the tone that we're putting in. You can see I'm adjusting that. That's the modulation level there. This is the signal level over here that we're putting in. Make it go away. Just a little bit's all it takes, close as it is. But that's the IF signal being fed into the antenna. Well, actually, not into the antenna, but coupled with the antenna there by RF. So we're gonna tune the radio now. That's one in right there, and we're gonna go around here, and you can hear the tone stays pretty constant. So what that shows, as we get to the end here, here's the other end. What that shows is the fact that the radio itself is working. In other words, the IF signal, it's an RF signal being fed into the antenna, coupled again with RF. So you can move this around a little bit and it'll still work. You can see it. You get a little bit further back, it's not quite as strong, but when it's laying right up against it, it works pretty good. But again, that's what we're looking at is an IF signal being fed into the radio. The radio works, audio works, and we can hear that tone just fine. Again, there's our voltage being fed into the radio, 104 volts, 0.5, 6, whatever it is. So we know again that the radio is working. Now, what would cause the problem that we're having? No stations coming in. Well, we know the antenna works because we're just, like I said, we're doing that. The RF has to be working because it's being fed. It goes in through that. It goes into the converter and goes on down through the whole radio. The signal does. But there is no signal being fed into the radio as far as station. I mean, we're not getting any stations at all, and I know we have one strong station, 1390 here in Seymour, and that comes in no matter what. So what's our next step? Alright, so we're back again, and again we have no reception. What we're going to do now is the most common, and I'm just saying, I know the problem obviously is no oscillator, but the most common problem in this case is no local oscillator. So to prove it's the local oscillator, what we're going to do is feed another signal into this antenna coil from the signal generator, and normally again, the 1390 is my strong station, so I've already got the radio set to 1390 on the dial. If I had a dial, we could do that, but I've cheated and done it without the dial, so I know where it's at. But in order to get that come in, you need an IF or an oscillator frequency of 1845 kilohertz. Okay, so we can't get that on the RF generator and feed it in through the RF because that's out of the RF range. In other words, 1300 or 1500 is the limit on that. So 1900 or 1800 won't come in through there. I've done tried it; it doesn't work. But here's another thing: harmonics. The main harmonic of that would be half that frequency, or 920 something, roughly. So what we're going to do is feed that in and see what happens. It is working. I don't know if you can hear it. I'm going to tune it in a little bit. And that's being fed there. So see when that happens when I go away. I'm basically feeding in a local oscillator signal. So that proves right there that the problem is our local oscillator is not running. So don't want to get too bad a hit on that. But that proves our point, and it shows that the local oscillator is not running. I'm going to show you the frequency we're running at. You can see that's 922 kiloohms is what's being fed into the antenna coil there, and that makes it work. So just that simple. That's how you can prove the fact that your local oscillator is not running. And the next thing you would do is go into your component level testing and find out why that oscillator is not running. In this case, I've simply disconnected 2 wires there. That's the wires for the push button switches on the back here. There's 2 sets of contacts there. I've just got one of them soldered together, and the other one I usually had soldered together, but I disconnected it. That's the one that feeds the local oscillator. So that's how I got the local oscillator to quit. So, but if you just, I'll demonstrate this too. Here, let me put that down just a second. Keep these clip loose. Alright, as soon as this thing warms back up again, we should have, I'll go ahead and turn this back off. We should have some audio coming here shortly. Up to around 105 volts now. And we can tune this in. There's our station. See, I've got my local oscillator. I'll hook back up again. So, anyway, that's how you test for that. It's not a big deal. And so that shows you how you can use the signal injection there to prove there is a problem with the local oscillator. Now, there's another method of doing this, and I'm going to demonstrate that too, so if you just hang in there just a second. Alright, back again. I have the radio still playing now, or playing. I'm going to show you what we did. Instead of feeding in at the antenna, I no longer have the antenna coil hooked up, but instead I'm hooked up directly to the grid of the oscillator tube. I'll show you the point on the schematic. Put that here. And you can see now the frequency 1845. Okay, that's the actual what kind of frequency I needed to get this station in. It's a little bit weak, but again, that can be partly because of this. Signal level just needs to be pretty close right on. And like I said, anytime you start messing with frequencies like that, the way I'm putting it into the radio and everything involved, it's just not going to be perfect, obviously, as it would with the radio. So there's just a couple of methods there. I'm going to turn this off because that's just killing me. There's a couple, that just shows there's a couple methods of testing for no local oscillator using signal injection. Now, it could be done with signal tracing, but not as easy, because your signal tracing is not going to pick up at the RF stage like a radio. It's simply not it won't do it. I mean, it would pick up any frequencies there, but it just doesn't work the same way as a radio would work. So like I said, the best way is the signal injection on this one, and I hope that I've covered that pretty good. And again, I don't know how else to do it. That's just pretty much it. There's like I said, with the get this off. With the signal, or with the loss of the local oscillator, it's just a little bit difficult to prove, or to fix, or to track down, I should say. Again, you go into, after you find out it is a local oscillator, you go into the troubleshooting for the stages. I put up a link in the description that is pretty good method of troubleshooting each stage of the radio when you find out which stage it's in. And for this one, it would be a little difficult even using that method, because it doesn't really cover the way I disabled the local oscillator with this switch. Like I said, I just did it because it was quick and easy to do. I knew by disconnecting those two lines, and I'll show those on the schematic also. So this is a quick one. I'm not going to make a long one out of this because I'm going to piece these pieces together. But I just wanted to show you basically how you can troubleshoot no local oscillator using signal injection. And there's a couple methods right there you can use. And I urge you guys to input some other types of problems. What I want to do is try to go through every stage if I can, and show what happens when you lose a certain component in that stage, things of that sort. I have a couple more scenarios that I'm going to follow out here. It's a couple of again, you guys that know all about this stuff know things that are hard to troubleshoot using this method. And basically we'll show you on those and any way we can to troubleshoot them with the signal injection or signal tracing. So that's about it for this time, guys. I hope you guys have a great day, and thanks for watching.